Given a kite is flying at a height of 3 meters and 5 meters of string is out, if the kite is moving away horizontally at the rate of 200 centimeter per second, find the rate at which the string is being released. So let's take the diagram. Let's consider h as the height of the kite. So this is the ground level and this is the string is released. Say this is x, say this is y ground, and it is given horizontal at the rate of 200 centimeter means which is parallel the base. So we can say dy by dt is equal to 200 centimeter per second, and it is also given h is equal to 3 meters which is fixed, and 5 meters of string is out means x is equal to 5. So we have x square is equal to y square plus h square, or we can add y square is equal to x square minus h square, that is 5 square 25 minus 3 square 9 16. So y is equal to 4 we can consider. Now by using the relation here, x square is equal to y square plus h is a constant, so we can add 3 square, that is 9. Now differentiating with respect to t, so we have 2x into dx by dt is equal to 2y into dy by dt, or we can write 2 into the value of x is given 5 into dx by dt, which is equal to 2 into y value is 4 into dy by dt is 200 centimeter per second. So dx by dt is equal to 2 into 4 into 200 divided by 2 into 5. So we may cancel here 5 40 times. So 40 into 4 is 160. So dx by dt is equal to 160 centimeter per second. Is the rate of change, the rate at which the string is being released. X is representing the string length. So 160 centimeter per second is the answer. According to a psychologist, the ability to a person to understand spatial concepts is given by A is equal to 1 by 3 root t. That is A is equal to 1 upon 3 root t is one function given where t is the age in years. T belongs to 5 comma, t belongs to closed interval 5 comma 18 means from 5 to 18 years. Now we need to show that the rate of increase of the ability to understand spatial concepts, that is dA by dt. This is rate of increase of ability to understand the spatial concepts will decreases. So dA by dt decreases for t in between, for t belongs to 5 comma 18. So this is what we have to show. So let us consider this dA by dt is equal to some function like f. Now to show that the function f decreases means we need to show that df by dt should be less than 0. That is d by dt of dA by dt must be negative. That is second order derivative d square a by dt square should be less than 0 for t belongs to 5 comma 18. So let's consider a is equal to 1 by 3 root t and differentiate dA by dt is equal to 1 upon 3 into root t differentiation is 1 by 2 root t, that is 1 by 6 root t. And again now d square a by dt square second order derivative we can write 1 upon 6 into t to the power of minus 1 by 2 plus 1, sorry, minus 1 by 2 minus 1 into minus 1 by 2. So that is minus 1 by 12 t to the power of minus 3 by 2. So we can write d square a by dt square is equal to minus 1 by 12 times of t to the power of 3 by 2 or t root t. And for t belongs to 5 root 18, 5 comma 18, we can say t root t must be positive. So we can say minus 1 by 12 times t root t must be negative. So d square a by dt square is negative. That is dA by dt is decreases. So we can say that, and hence we can prove that the rate of increase of the ability, that is dA by dt is decreases with the age in between 5 and 18. So hence proved. Given an ant is moving along the vector L1, that is I minus 2j plus 3k, and few sugar crystals are kept along the vector L2, that is 3i minus 2j plus k, which is inclined at an angle theta. So let us consider L2 is another vector which is inclined at an angle theta, means angle between the two vectors is theta here. Then find the angle theta. Also find the scalar projection of L1 on L2. So first let us find the angle. If theta is the angle between the two vectors, then we have cos theta is equal to L1 dot L2 divided by mod of L1 into mod of L2. That is I minus 2j plus 3k dot product with 3i minus 2j plus k, and let us write here mod of L1 is equal to under root of 1 square plus minus 2 whole square plus 3 square, that is under root of 1 plus 4 plus 9, that is root 14. So we can write divided with here root 14, and similarly mod of L2 is equal to under root of 3 square plus minus 2 whole square plus 1 square, the same values we have, so we can write root 14. So into root 14, and simplifying 1 into 3, that is 3, minus 2 into minus 2, that is plus 4, and plus 3 into plus 1, that is 3. So divided by root 14 into root 14 is 14. So 3 plus 3 is 6, 6 plus 4 10, 10 upon 14, or we can write 2 5s are 2 7s are. So we have cos theta is equal to 5 by 7. So which implies the angle theta is equal to cos inverse of 5 by 7. And now we need to find the scalar projection of L1 on L2. Scalar projection of vector L1 on L2 is given by L1 dot L2 vector divided by mod L2, means unit vector of L2. So we can write L1 vector. We had L1 dot L2 is nothing but 10, we can say from here. So 10 divided by, and mod of L2 is root 14. So 10 upon root 14 is the answer. We need to find the vector and Cartesian equation of the line that passes through minus 1 comma 2 comma 7 and is perpendicular to both the lines given. So here are two lines. Let us consider. Here is one line which is passing through the point 2 comma 1 comma minus 3 and having the direction ratios 1 comma 2 comma 4. So direction ratios means we may consider the parallel vector. Having the direction ratios 1 comma 2 comma 5, and another line passing through the point. Let us consider another line here passing through the point 3 comma 3 comma minus 7 and having the direction ratios here 3 comma minus 2 comma 5. So that is having the parallel vector. So parallel vector direction ratios are given 3 comma minus 2 comma 5, and we know that there is a vector which is perpendicular to this both the vectors, parallel vectors. So let's extend here. There is a perpendicular to these two vectors can be considered to be as, if you consider this is b1 vector and this is a b2 vector, and here this is b1 cross b2. So b1 cross b2 will be the perpendicular to both the vectors, or we can also say both the vectors here, both the straight lines, given lines, this vector is perpendicular. So let's find b1 cross b2. So determinant of I, j, k, b1 vectors. So we can add 1, 2 and 5, and b2 is 3 minus 2 and 5. Upon simplifying, we get I times of 5 2s are 10, minus of minus 10, that is 20, minus j times of 1 into 5 5 minus 15, 5 minus 15 is minus 10, next plus k times of 1 into minus 2 minus 2 minus 6, negative 2 negative 6 is negative 8. So which is 20 times I plus 10 times of j minus 8 times of k. So this is b1 cross b2, or we can also consider to be by taking 2 common, 10 times of I plus 5 times of j minus 4 times of k vector. Now we know that the equation of the line passing through the point minus 1 comma 2 comma 7, the vector equation we can write passing through the point, let us consider this position vector is a, r is equal to a plus some scalar b lambda into b vector. B vector is a parallel to this, so we may consider b1 cross b2. So r is equal to a vector plus, that is minus I plus 2j plus 7k, this is vector a, plus lambda times of b vector, that is b1 cross b2 we can write here, which is a parallel vector. So here I can write 2 times or 2 lambda of 10I plus 5j minus 4k, or this can also be written minus I plus 2j plus 7k plus, we may consider this as something lambda 1 times of 10I plus 5j minus 4k. And then the Cartesian equation, we can write, since passing through the point x minus x1 upon the direction ratios a, y minus y1 upon b is equal to z minus z1 upon c is the equation of the line passing through the point x1 y1 z1. So here x1 y1 z1 is minus 1 2 7, so we can write x minus of minus 1 divided by the direction ratios will be considered to be the b vector, that is b1 cross b2. So we may consider 10, which is equal to y minus y1 is 2 divided by 5, which is equal to z minus 7 upon, and here it is negative 4. So we can write x plus 1 upon 10 is equal to y minus 2 upon 5 is equal to z minus 7 upon negative 4. So here is the answer. It's a Cartesian equation. So this is Cartesian, sorry, Cartesian equation and this is a vector equation. We need to find out integral 1 upon log x minus 1 upon log x whole square dx, where x is greater than 1 given. So let us substitute or put let log x is equal to t. So which implies x is equal to e to the power t. And then differentiating with respect to t, so we get dx is equal to e power t dt. So we can write here integral 1 upon t minus 1 upon t square into dx is nothing but e to the power t dt. It is in the form of, and since we know the differentiation, d by dt of 1 by t is equal to minus 1 by t square, and hence it is in the form integral f of x plus f dash of x into e power x dx is equal to e power x f of x plus c. So here f of t, it is in the form like f of t into e power t plus some constant, because 1 upon t differentiation is minus 1 by t square. So this can be written like 1 by t plus of minus 1 by t square f plus f dash into e power t. So we can write f of t is nothing but 1 by t into e power t plus c, that is 1 upon log x, substituting back t is equal to log x into e power t is x plus c, that is x upon log x plus c is the answer. Evaluate integral 0 to 1 x into 1 minus x whole power n dx, where n is a natural number. Let's use the property here, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So that we can write integral 0 to 1, in place of x we can write 1 minus x into, here 1 minus of 1 minus x whole to the power n dx. Integral 0 to 1, 1 minus x into 1 minus of 1 minus x can be taken as x. So x to the power of n dx, which is integral 0 to 1 x power n minus x to the power of n plus 1 dx. Now integrating, we'll get x to the power of n plus 1 upon n plus 1 over the limits 0 to 1 minus x to the power of n plus 2 divided by n plus 2 over the limits 0 to 1. So the upper limit is 1. So 1 to the power of n plus 1. Since n is a natural number, so we can take it as 1 divided by n plus 1 minus 0 power finite number is 0, and again minus of 1 to the power of n plus 2 is 1 divided by n plus 2 minus 0 power finite value is 0. We can add 1 upon n plus 1 minus 1 upon n plus 2. So which is equal to n plus 2 minus of n plus 1 divided by n plus 1 into n plus 2. So that is 2 minus 1 is 1 upon n plus 1 into n plus 2 is the answer. So given a linear programming problem LPP, to minimize z is equal to x plus 2y, and subject to the constraints here, 2x plus y is greater than or equals to 3 and x plus 2y is greater than or equals to 6, and x and y both are positive, greater than or equals to 0, which represents in the first quadrant. Let's see the graph. Let's take first one. 2x plus y is greater than or equals to 3. When x is equal to 0, we can say from equation 2x plus y is equal to 3 to get the straight line. When x is equal to 0, y is equal to 3. And when y is equal to 0, we can say x is equal to 3 by 2. So let us mark these 2 points, 0 comma 3 and 3 by 2 comma 0. So here is a straight line which is representing 2x plus y is equal to 3, and the half plane, that is 2x plus y greater than or equals to 3, which will be against to the origin, because 0 comma 0 if I substitute, when x is equal to 0 and y is equal to 0, so we get 2 into 0 plus 0, which is 0, is greater than or equals to 3 is false. So we can conclude that origin is not satisfying the half plane. So the shaded region will be away from that, away from the origin. And now let us see another one. X plus 2y greater than or equals to 6. When x is equal to 0, for the equation of the line 2x plus x plus 2y is equal to 6. When x is equal to 0, we can say y is equal to 3. And when y is equal to 0, x is equal to 6. So let's mark these 2 points. 0 comma 3 is the point here, and another one 6 comma 0. Let's mark 6 comma 0 here. So here is a straight line. And now coming to the inequality, x plus 2y greater than or equals to 6, the half plane. And here also we can see when x is equal to 0 and y is equal to 0, 0 plus 2 into 0, that is 0, 0 is less than 6. So but 0 greater than or equals to 6, which is false. So we can say the shaded region to be against to the other than origin, means away from origin. Origin will not satisfy, so we have to sketch the graph. The half plane is other than that, and hence we can conclude this is a feasible region, and this is x is greater than 0, y greater than 0. And now we have the corner points, two corner points. Say this is A and say this is B. So A point 0 comma 3 and the point B 6 comma 0, and the value of this profit function, that is z is equal to x plus 2y. If I substitute here, you will get 0 plus 2 into 3, which is equal to 6, and here 6 plus 2 into 0, which is equal to 6. At this both the points you are getting the same value 6. And also now we need to decide whether this linear programming problem LPP have the minimum value or not. By taking the inequality, we need to consider the inequality from the profit function, that is x plus 2y, and since we required minimum, so less than, and this value is 6. X plus 2y less than 6, which is our the second line equation. X plus 2y is equal to 6, which also represents, this is representing this line joining A and B. This is the line equation, and clearly we can see that less than 6 means which is satisfying the origin. 0 plus 2 into 0, which is 0, is less than 6, true. So the solution for this inequality is towards the origin. And even it does not touch the line because it is strictly less than 6, and hence we can say there is no common solution. There is no common solution with the feasible region. We got an empty set. Since we got no common solution, and hence we can say that the given LPP has the minimum value. And but still it since it gives two values same 6 and 6, and also we can observe that any point on this line joining these 2 points a and b, that is x plus 2y is equal to 6 equation. Let us consider 2 comma 2 point at x is equal to 2 and y is equal to 2 also satisfies, and remaining any other point joining these two line points also satisfies. Hence we can say there are we can say more than 2 points, which gives the minimum value. So graphically we can just prove it. The minimum of z occurs at more than 2 points. Okay. Given the probability that it rains today is 0.4. If it rains today, the probability that it will rain tomorrow is 0.8. If it does not rain today, then the probability that it will rain tomorrow is 0.7. So today, for raining, the probability is 0.4. For not raining is 0.6. Means no rain. And in the case of tomorrow, we can see that again, if it rains or if it no rain. In the case of no rain, again if it rains and no rain. It's mentioned if it does not rain today, the probability that it will rain tomorrow is 0.7. So here is a 0.7. Then no rain will be 0.3. And if it rains today, the probability that it will rain tomorrow is 0.8. So here is a 0.8. Then no rain is 0.2. So if P1 is P1 denotes the probability that it does not rain today. Means 0.6. So we can say P1 value is 0.6. And if P2 denotes the probability that it will not rain tomorrow, if it rains today and no rain tomorrow is 0.2. So P2 value is 0.2. P3 denotes the probability that it will rain tomorrow. Tomorrow there is a rain either here or here. If it does not rain today, so there is no rain today. So that is 0.7. So we can say P3 is 0.7. And P4 denotes the probability that it will not rain tomorrow. There is no rain tomorrow. If it does not rain today, means no rain today, means 0.3. So we can say P4 value is 0.3. Then we need to find the value of P1 into P4. So P1 is 0.6 into P4 value is 0.3 minus P2 value is 0.2 into P3 value is 0.7. So which is 0.18 minus 0.14, which is 0.04 is the first answer. And coming to the second one, calculate the probability of raining tomorrow. So let us consider the events. Let A be the event, raining tomorrow. Again here two cases arises. Let us consider E1. if rains today, and E2 if no rains today, if no rain today. Then we can write probability of E1 is probability of E1. Let me write here. Rains today is 0.4 and probability of no rain today is 0.6. Now let's consider probability of when raining tomorrow, given that if it rains today, that is P of A by E1, if it rains, probability of raining tomorrow when it rains is 0.8. And similarly probability of raining tomorrow given that it is no rain today, that's nothing but raining tomorrow if there is no rain today means 0.7. Now by total probability of raining tomorrow can be taken as P of E1 into P of A by E1 plus P of E2 into P of A by E2. So which is equal to P of E1 is 0.4 into 0.8 plus P of E2 is 0.6 into 0.7. So here we can write 0.32 and plus here 0.42, which is 0.74. So 0.74 is the answer for the second question. The probability of raining tomorrow can be taken as 0.74 answer. Okay. Given a random variable x can take all non-negative integral values, that is other than negative values, all positive and zero values can be taken integral values, and the probability that x takes the value r is proportional to 5 to the power of minus r, that is probability at x is equal to r is proportional to 5 to the power minus r, which can also be taken as probability at x is equal to r is equal to some constant k into 5 to the power minus r, that is k divided by 5 power r, and we need to find the probability for x less than 3. So let's write here probability at x is equal to 0, we can write k divided by 5 to the power 0, that is k upon 1, which is equal to k, and probability at x is equal to 1 is equal to k divided by 5 to the power 1, that is k by 5, and probability at x is equal to 2 is equal to k divided by 5 square, that is k by 25, and so on we can find. And since we know that the sum of the probabilities is equal to 1, so we can write p of at x is equal to 0, probability at x is equal to 1, p at x is equal to 2, and so on, which is equal to 1. So we can write k plus k by 5 plus k by 25 plus and so on is equal to 1. We can take k common and we can write here 1 plus 1 by 5 plus 1 by 5 square, that is 1 by 25, and so on is equal to 1, which is a geometric progression. This is a geometric progression with the first term a is equal to 1 and r is equal to 1 by 5, and we know that sum to infinity formula is a upon 1 minus r. Here r is less than 1, so we can write k into 1 divided by 1 minus 1 by 5 is equal to 1, that is k into 5 divided by 5 minus 1 is 4 is equal to 1. So we got the value of k is 4 divided by 5. So once we got the value of k, so now we need to find the probability x less than 3. Now p at x less than 3, which is equal to p at x is equal to 0 plus p at x is equal to 1 plus p at x is equal to 2. That at x is equal to 0, we can say now k value, that is 4 by 5, plus at x is equal to 1, we can write 4 by 5 into 1 by 5, and at x is equal to 2, we can write 1 by 25. So 4 by 5 taken common. 1 plus 1 by 5 plus 1 by 25. That is 4 by 5 into. So here it is 25 plus 5 plus 1 divided by 25. So 25 plus 5 30, 30 plus 1 31, 31 fours are. So we can write here 124 divided by 25 fives are 125. So 124 upon 125 is the answer for this question.